So let us do this multi-step synthesis, except we are given the scheme and we had to find out what the structure of each of these question marked species are. So we are starting with an acid chloride and we are getting this ketone, which means you should probably start with the benzoyl chloride and react that with the Gilman reagent so that the carbanion nucleophile reacts only once. If you use a Grignard, it's going to not stop at this stage. The Grignard is going to further react with the ketone and it will give you the a tertiary alcohol. Therefore, that's the Gilman reagent you have to react that with. And of course, treat this with acidified water after reacting it. So Gilman reagent with the acid chloride is going to give you this ketone. And once you get the ketone, you are reacting it with catalytic amount of acidified water and bromine. So the bromine is going to be the monobromination product is going to give the monobromination product because you form the enol because of the acidified water, and Br2 is going to react as an electrophile, right? So you get alpha bromination. So the bromine hops onto that carbon and it will give you that. Now when you treat this with pyridine, the pyridine is going to abstract that hydrogen and it will give you dehydrohalogenation and you will get the alpha beta unsaturated ketone. So you're going to get that product. Now this product reacting with the product of this side reaction, which is ethyl lithium reacting with cuprous chloride. You're removing one molecule of lithium chloride when two molecules of this react with that. So this is obviously, as you would know, is a Gilman reaction that produces the Gilman product, or it's the reaction that gives you the Gilman reagent, right? So this again is dialkyl cuprate. So minus lithium plus, that's what the product of this reaction is. So when Gilman reagent reacts, it is going to be the donor and this is going to be the Michael acceptor, and therefore you will produce the product of conjugate addition on the beta position. Okay, so if you call this carbon atom 1 and 2, that is 1 and that is 2. If this is 3, let's change some colors there. If you change this is going to be, let's say 3 and 4, then 3 and 4. That's what happens. But the only thing is, since you did not treat this with acidified water, you are going to get the corresponding anion. Okay. Now when this anion is present in the medium and if you treat that with ethyl bromide, you're going to have a substitution reaction. So you will get 3, 4 and here, so 1, 2, 3, 4, 1, 2, 3, 4, and at the alpha position you're going to get the ethyl group there. So 1, 2, 3, 4, and let's call this side chain A and B. So that is A and that is B. Now that's the product you'll get from the treatment of ethyl bromide to this carbanion. And now what happens if you react this with the product of this reaction, which is if you take ethyl bromide, treat that with magnesium, what do you get? You'll get the Grignard reagent. So you're going to make ethyl magnesium bromide, and when you treat this ketone with ethyl magnesium bromide, you're going to get a reaction on the carbonyl carbon here. So the product of this reaction is now going to be minus 1, 2, 3, 4, 1, 2, so 4, and this is A and that is B, and now let's call this X and Y perhaps, and now you'll have X and Y. So therefore the final product is going to be the phenyl ring and alcohol, and then a 2 carbon chain there, and 1, 2, 3, 4, and then a 2 carbon chain over there. So that is the final product, and if you call this X and Y, that is X and that is Y. So that's the multi-step synthesis there.